Hi, welcome all. In this video, we will discuss how different mathematical functions can be plotted. For instance, how sine function, cosine function, exponential function, etc. can be plotted using NumPy module and matplotlib module. Okay. Okay. So in order to plot a particular mathematical function, we have to generate an array or sequence of independent variables and the function values at that points. For instance, suppose you wish to plot f of x where x is the independent variable. You must have some sequence x0, x1, etc., xn, and you must evaluate the function values at that point, f of x0, f of x1, etc. So you must have two sequences. For convenience, let us call this sequence as x and this sequence as some y. So you need basically two sequences, namely sequence x and sequence y. X is the sequence of x is a sequence of independent variables, and y is the function evaluated at those points, right? So we will discuss about plotting sine function or cosine function, sine or cosine function. We will discuss how an exponential function is plotted, or in general any function. Okay, so the basic idea is this. Let us first consider the example of sine. How do we plot sine function? We know that in NumPy module there is a built-in function, that is sine, whose argument is angle, and this angle must be in radian. So this function will return the sine function. Suppose you wish to find a plot sine versus some angle, say theta versus sine theta. What we do is we first fix the minimum value of theta, theta 0, and we'll fix the maximum value of theta, say theta n. So for instance, let it be 0 radian and some 6 pi radian, say. Now we will divide these points into some finite number of equally spaced points, say some 1000 points, right? And for that we have our linspace function. So you can generate theta function something like this. So let me call this as some x, sequence x. X can be generated as np dot linspace of 0, 6 pi, and for my convenience let me first write 6 pi, but basically you must write it as 6 star np dot pi. Then we will divide that into some 1000 points. Next point is this: we have to evaluate the y sequence. Since x is an array, you can generate the sine of all these angles just by calling sine function np dot sine, and we pass the argument as x. So this will generate x and y. Then it is very simple to plot. We can use the plot function available in the matplotlib, plot x, y, and you can definitely decorate the sequences. You can add title, you can add x labels, you can add y labels, etc. Okay, now if you wish to plot cosine instead, the only change is here, instead of sine you can write cos. And if you wish to plot exponential, definitely you can make the change something like this: np dot exp of x. So there you can change the x values if you wish. So this way you can generate the y sequence corresponding to the sequence of independent variable, and you can plot this thing. Okay, So we will see the execution of this one in Python. Okay, so we'll consider the example of sine function. So for that, let me take a new file. We'll write the code for that. So plotting mathematical functions. Okay, the first step is to import numpy as well as matplotlib.pyplot. So we do that, import matplotlib.pyplot as plt. The next step is to generate the sequence of x and y. So we'll call x as x equals np dot linspace. So as we discussed in the illustrating example, we'll choose the minimum value of theta as 0 and the maximum value as some 6 pi. So 6 star pi, np dot pi. So 6 pi, and we'll choose some 1000 points in between. Basically 1000 point is really large. We'll choose some 200 points. Okay, and y equals np dot sine of x. Since x is an array, this statement will convert all the values in the x sequence into sines. So this will be a sequence of sine evaluated at all x points. So we have both the sequence. Next step is to plot it. So we'll use plot function, plot plt dot plot x comma y. That's it. So this will generate the plot, and we will add one more comment to see it, plt dot show. So it's okay. Now if you wish, you can add titles, labels, etc. So I'm leaving this as an exercise for you. So we will run the code. Before that, we will save it as save as. Plotting mathematical functions. Okay, so we'll run the code. Okay, the sine function is ready. You can see it. So we know that sine 0 is 0 and sine 6 pi is again 0, and sine 6 pi means sine 3 into 2 pi. So sine is periodic in 2 pi. That means you can see 3 periods, 1, then 2, then 3. So you can see the waveform. So you can decorate your graph. Now I wish to see how cosine function look like. It's really simple. You can change this function as cos. We'll see the result. So it's very simple. It starts at 0. So at 0 degree it is at 1. Then again it oscillates in every 2 pi. So this is as simple as it is. Okay. Now you may try exponential sequence and exp of x, and for exponential sequence we will change this maximum limit as some e raised to 5 or something like that. So we shall see that. Okay, it's exponentially growing. Okay, so e raised to 5 is 140. So this way you can plot any mathematical function according to your wish. Fine. Next we shall see how Bessel function can be plotted. We know that Jn of x is given by this polynomial expression. Jn of x equal to summation s equal to 0 to infinity minus 1 raised to s divided by s factorial into n plus s factorial x by 2 whole raised to 2s plus 1. So this is the polynomial expansion of Bessel function. The zeroth term t0, you put s is equal to 0, you will get this one as 1 by n factorial into x by 2 whole raised to n. Now if you find the ratio of pth term and p minus 1th term, that is tp divided by tp minus 1. So you just put s is equal to p, then you will get tp at the term, and you put s equal to p minus 1, you will get tp, mean p minus 1th term. So we will calculate pth term and p minus 1th term, then we take the ratio pth term divided by p minus 1th term, and you can easily show that that will be equal to negative 1 divided by p into n plus p into x by 2 whole square. So this really helps us to calculate the pth term. You just start with the 0th term, then you can calculate the first term by multiplying that with this factor. Alright, so we can calculate the pth term, present term, as previous term into this factor minus 1 divided by p into n plus p x by 2 whole square. Okay, so using this technique we can consider an algorithm to find out Bessel function. Definitely you cannot find the exact value of Bessel function using this polynomial expansion, because this is an infinite sequence. You cannot consider all the terms, but the first few terms will make it sufficient, and you will get the approximate Bessel function with the acceptable accuracy. So we'll use few terms only. So adding more terms will not change it considerably because of this factorial term here. Because you know that for very large values of factorial, the denominator become very large, and as a result the term become very small, and due to that reason Jn of x can be approximated to a finite sequence. Some few terms only are sufficient, to find out the approximate value. So what we do is we'll define Jn of x for a particular n and x. How will you calculate Jn of x? So for that we will just start with the term 0th term, that is x divided by 2 raised to n. So x divided by 2 raised to n. I translated this into Python first. Then I have to divide that with the n factorial. So we know that in math function there is factorial. So m dot factorial. Fine. Now we will use j as the variable to store the value of Bessel function at that particular n and x. So initially we set that to t, that is t0. Then we will repeatedly calculate the next term from the previous term. So the present term is equal to, this is the algorithm, the present term is equal to past term, the previous value of the term p minus 1 into this parameter. So here we must run p from 1 to a particular value. So we consider only 10 terms. You may add more terms while you try, you may add more terms, and you can see how it differs. Okay, right. So for p in range 1 to 10, so what we do is we are going to repeatedly calculate this term using this iterative formula. Present term t is equal to previous term into this factor. So this factor is for t into previous term, that is t into then negative 1, no? So that negative sign I put it here, negative. Then we have x square, this one x square, then divided by, you have to divide that with the p, then divide that with n plus p, then divide that with the 2 square, that is 4. Alternately you may divide that with the whole term multiplied, p into n plus p into 4. So that is up to you. Okay, and that way you can calculate the next term. Okay, so the term is added to j, so j is equal to j plus t. So this is a shorthand for that. Let me use pen, we'll write that here. uh, okay, so basically alternately you may write it as this equation may be written as negative t star x star star 2, then divided by whole terms, this much terms, divided by uh, p star p plus n star 4. So this will also do, and this is equivalent to j equals j plus t. You know that shorthand. Okay. Okay, then we'll calculate such 10 terms. So altogether there will be 11 terms, sorry 10 terms. 0th term we'll calculate initially using this formula, and 9th term we calculate, up to 9th term we calculate using this loop and added to that j, and we will return that j. So this function can be used to evaluate jn of x at a single point. Fine. Now as we have done earlier, we'll use this function to generate a sequence of jn of x, and that is very simple. In the previous case, x is equal to linspace, we have choose the minimum value of x, maximum value of x, and the number of points. Then we call y as say in the previous example sine, we just call it as y is equal to np dot sine of x. Instead here we'll call y is equal to jn of x. So this will generate all the corresponding sequence, because x is an array, all the elements will be evaluated. Now we will plot as before. Okay, so that's the logic. So I shall express the logic once again. I shall explain the algorithm once again. How to evaluate jn of x at a single value of n and x. Okay, the logic is very simple. We first evaluate the 0th term to begin with. Then the first term can be calculated like this. Put p is equal to 1, then t0. t0 into tp means p is equal to 1. So t1 is equal to t0 into minus 1 divided by 1 into n plus 1 x by 2 the whole square. This way you will get first term. So we know the initial term t0. We calculate the first term and add that to the jn of x. Then we will calculate the second term using the first term. Okay, so on and so forth. We just choose 10 because 10 itself is sufficient. 11th term, 12th term, etc. are negligibly small. You may try that. Okay, so we repeatedly calculate the present term using the past term and add that to the jn of x. So we will calculate such 10 terms. So that means basically after this iteration, j contains sum of first 10 terms, 0th term, first term, second term, etc. up to 9th term. Okay, so then we will return that value. So basically what we have done is, there is no built-in function, so we defined a function for evaluating jn of x. Okay, but in the previous examples where we plotted sine or cosine, we had a built-in function, but we don't have jn of x to we don't have any built-in function, so we define that. So while you practice, I request you to change this number and see the difference. Okay, all right, you can see the code, so let me run it. So this is the Bessel function for n is equal to 2. Please note that I have set n is equal to 2. So you may try for other values as well. So this is left as an exercise for you. Okay. So we have discussed how mathematical functions like sine, exponential, cosine, logarithm, etc. can be plotted. And we have also seen how to plot special function, Bessel function, and similarly you can plot any other special function like gamma function. It's there in the syllabus, so I'm giving you this as means plotting of gamma function as an exercise for you, and I request you to copy this code and try with different parameters. For instance, in the Bessel function you may try with the different n values, and you may add the number of terms required in the sequence. Okay, thank you all.